This is geometry 9.5. We're talking about arc measures. An arc is part of a circle. So when we think about a circle, an arc is part of the circumference. Any part of that circumference, a portion of it will become an arc. So when we talk about a central angle has a vertex at the center, and it comes over and it touches the circle at two points. So a central angle has a vertex at the center of the circle. That would be a central angle. Now notice how the central angle touches the circle. It kind of defines this arc. We would call this the intercepted arc. That is the arc formed by the central angle. A minor arc. A minor arc will have a measure that is less than 180 degrees. So here we have our circle. And if we put a central angle in there, we now have this arc that's being formed. And this arc would be right here. We'll name this arc with an A and a B. So the name of this arc is AB, and we put a curve over the top for arc AB. We'll go back up to our central angle. We'll put an A, a B, and we'll name the vertex. You could use any letter you want. I'll use O. It's the center of our circle. So this angle, this central angle, of course, just like it has been in the past, would be AOB. Angle AOB. Where this arc, we're using two letters. Two letters to name it. Arc AB. A semicircle. Well, let's draw it. Let's see it first before we talk about it. A semicircle is going to take our diameter, and a semicircle is half the circle on either side of a diameter. So its measure is exactly 180 degrees. Three letters to name it. So in this case, if we were to use our semicircle, that would be DAB, arc DAB. So we put our curve over DAB, and we need to use 3 letters to name it. To our last one, which is a major arc. We have some points on our circle. A major arc is going to be greater than 180 degrees. Measures more than 180 degrees. 3 letters to name it. So notice the notation. We use 2 letters to name a minor arc, 3 letters to name a semicircle, and 3 letters to name a major arc. So you'd start at one of the ends to name your arc. So A seems like a logical spot to start. Then you would go in the direction of the arc. Since the purple is heading to the left, I would do ADB. So the measure of the entire circle, we go all the way around the entire circle in terms of a degree, we would be saying that it's 360 degrees. If a dog's chasing its tail, it's going to be running in 360 degrees to chase that tail, because it goes around in a full circle to do it. The measure of a minor arc is the measure of its central angle, and the minor arc is always less than 180. That we've talked about, less than 180. But let's talk about the measurement of this arc. It's the measure of its central angle. So that means this arc right here, arc AD, is going to be the same measure as its central angle. Let's talk about what's happening so you get a good understanding of that. Here, if I turn it a little bit more like that, you can see it a little better. Let's call this a 90-degree angle. Okay? And we know that a full circle is going to be made up of 360. So the full circle would have 4 of those. Therefore, 360 broken into 4 equal pieces is 90. Whatever this angle is, the central angle is going to be the same. We call it a measurement, not a length, but a measurement of the arc. So the arc is 90 also. if we have a diameter we know that it's 360 all the way around a circle. Half the circle, what we call a semicircle, is going to be 180. Well, if you take an angle and you open up the angle all the way, you get an angle of 180. So this angle here would be 180 because it's not at 90 degrees, but it's opened up all the way to be 180, to be a straight line. So its central angle is equal to the arc. So those should be some visuals that should help you realize and make the connection that it doesn't have to be a memorized fact, but that it seems mathematical that the central angle, which could be anywhere in a 360 pattern, is going to be the same measure as the arc of your circle. So an example, AD is going to be the measurement of the central angle. It's going to be 50 degrees. The measure of the minor arc, the measure of the major arc is the difference between 360 and the measure of the related minor arc. And we know that a major arc is always more than 180. So let's talk about what that means. The measure of a major arc. So if this is 50, we're looking for the measurement of the arc going the other direction. All the way around to D. From D, B, D, that arc. They named it ABD, which is the same amount. What's that going to be? Well, it's going to be the entire circle, not counting the 50. So it's 360 minus the 50. So that's 310 degrees. Then we have a semicircle. A semicircle is half of the circle. A semicircle is always 180 degrees. We have to use 3 letters to name a semicircle. So they're saying start with A, then go to D, then finish at B. ADB. Arc ADB is 180 degrees. That would imply that AB was a diameter. If we know AD is a diameter, then we know one side of it is 180 and the other side of it would be 180. So here we're going to look at the bolded arcs and we're going to tell if it's a major or minor arc. So just so that you can see it well here, that's the arc we're talking about. So that's going from this point A to point B, so arc AB, and it is less than a diameter, it's less than half the circle, so it's considered a minor arc. From A to D all the way over to B, ADB. So we have arc ADB. So we put a curve over it to indicate that this is an arc. This is more than a diameter. It's more than straight across. It's more than half the circle. So this is a major arc. And then we have a semicircle, which is half the circle. We still have to use 3 letters. You can start with P, go to S, and finish with Q, PSQ, or you could start with Q, go to S, and finish with R. Your choice. Or it's not an R, sorry, that's a P. QSP. So PSQ would be an option, or you could go the other route, other direction, and say QSP. But it's an arc, so we put a curve over it. And that is a semicircle. It's half the circle. So we'll flip. Find the measure of circle C. So notice this circle with a dot in it. This is named, this is the word circle. Kind of like we have a triangle symbol and we say triangle ABC. Well, this is circle and we only use 1 letter to name it. We use the center point to name it. Circle C. Pretty common way to name a circle. Where segment AB is a diameter. So we know that this goes straight across. We don't have to pretend like it might be a little bit less. It's exactly straight across because that defines what a diameter would do. So we know we have a diameter in our circle. Also tell whether the arc is a major arc, a minor arc, I guess that's minor first, minor, major, or semicircle. So let's talk about the measure of arc DB. So D to B, you got to find that on your picture. Up here, to figure out this arc, it's going to be the same as the central angle. We talked about this earlier. The central angle is 135. So when we come up here, this will be 135. And it goes from the D all the way to the B. So if we're going to talk about the arc, the measure of this arc, from D to B, it's going to equal 135 degrees. Now we'll talk about D to A to B. We'll talk about the other direction, the rest of the circle. How do we determine everything but the 135 degrees? So 360 minus the 135 is going to be 225. So the measurement of arc DAB, notice the notation, you have to use an M, then you use capital letters, you put the arc curve above it, and that's going to equal 225 degrees. So that goes from the D all the way to the B at 225. Then we're going to finish with ADB. So you got to start at A, then you go to D, then you finish at B. That looks like half the circle. It goes from the end point of the diameter to the other end point of the diameter. And because they give us the letter D, it tells us that we are going specifically clockwise around our circle rather than counterclockwise. We need to use 3 letters, so that's the most logical way to name this one. So this is going to be the measurement of ADB using your notation correctly with the M, is going to be 180 degrees. Since this first example, letter A, was less than 180, this is considered a minor arc. Because this arc had 3 letters and was more than 180, it's going to be a major arc. And then if you have 3 letters that are exactly 180, that is a semicircle. Now, when we're talking about adding these and different parts of that's happening, moving around your circle, 2 arcs of the same circle are adjacent. What does adjacent mean? We know adjacent as typically about angles that are the same and they share the same vertex. In this case, with an arc, they have to share the same endpoint. So arc AD is adjacent to arc DB because they share the same endpoint and the arcs do not overlap. So 2 arcs of the same circle are adjacent if they don't overlap and they share the same endpoint. So an example would be going from A to D. That arc, notice I don't put an M with it, I just say AD, arc AD. So that arc and the rest of the semicircle would be a good example. Arc DB would be adjacent angles because they're side by side to each other, they have the same endpoints, and they do not overlap. So we're going to talk about adding these adjacent angles together. This is called the arc addition postulate. Well, we've talked about segment addition postulates, angle addition postulates. I think we've talked about area addition postulates. So now we're talking about arc addition postulates. And that's when we put 2 arcs together and add them up. The measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. So here we're looking at the measure of arc ABC. So from A to B to C. Well, that's going to be from A to B. So the measure of AB, arc AB, we put the curve over the top, plus the measure of arc BC. So the big angle is made up of the 2 small. Not the big angle, sorry. The big arc is made up of the 2 smaller arcs. Angle addition postulate. The small part plus the small part equals the big part. Just like we've talked about with all the other addition postulates. Okay, last one. The toughest part here is to draw the picture. AC and DB are diameters of circle E. So we have to start with circle E. So there's my circle E. I'm going to put 1 diameter in here. We'll call that AC, because that's one of the diameters. Now I could put the other diameter in here really anywhere we wanted to. In terms of the diameter, we don't know where it lies. But they're also telling us that the arc ACD, from A all the way to C, then finishing up to D, is supposed to be 316 degrees. Well, what does that mean? We know it's more than 90, more than a quarter of the circle. It's of course more than 180. It's more than just a semicircle. We have to do A to C to D. Well, if we came over here, which would be 3/4 of a circle, that would be 270 degrees. So now we have to go another portion to get to the letter D. This would end up being all the way around is 316 degrees. So what's the last little bit left over? That's going to be 360 minus the 316, which is going to give us 44. So the measurement of arc AD is 44 degrees. It is 360, not counting the big arc that we're referring to. Arc BC. Oh, we never drew in the other diameter. We have two diameters to draw in. So we have the original diameter, and then we have a diameter based off of where we put point D. So that would be B. All right, so what is this arc going to be from B to C? Well, we have 44. Then we come to our central angle, and we know the central angle is going to be the same as its intercepted arc. Well, vertical angles are the same, so this side is also 44. So its intercepted arc is 44. That doesn't mean that every small angle inside of a circle is the same arc, but because it has a central angle and it has a vertical angle, so therefore its arc is all going to be the same. Now we're looking at the measure of arc BCA. So you have to go from B to C all the way around to A. So that looks like a couple different ways we can calculate that. We have a diameter here. So that's 180 for a portion of it plus another 44. Or you could go the other way. You could look at the semicircle from B over to the D and then the additional 44. So this is 180 plus 44. So we get 224. And the last one is the measure of arc DCB, which is half the circle. So that's 180 degrees.